The mean and standard deviation of a discrete random variable. Mean of a discrete random variable. The mean of a discrete random variable x is denoted mu sub x, or, when no confusion will arise, simply mu. It is defined by mu equals the sum of x times the probability of x. The terms expected value and expectation are commonly used in place of the term mean. Find the mean of the random variable. The table below shows the probability distribution of the random variable x. When x equals 1, the probability of x equals 0.6. When x is 2, the probability of x equals 0.1. When x is 3, the probability of x is 0.3. Using the formula to find the mean, mu, we want the sum of x times the probability of x. So we want to multiply each value for the random variable x by its probability, then add those answers. 1 times 0.6 plus 2 times 0.1 plus 3 times 0.3. That gives us 1.7. So the mean equals 1.7. Interpretation of the mean of a random variable. In a large number of independent observations of a random variable x, the average value of those observations will approximately equal the mean mu of x. The larger the number of observations, the closer the average tends to be to mu. Standard deviation mean of a discrete random variable. The standard deviation of a discrete random variable x is denoted sigma sub x, or, when no confusion will arise, simply sigma. It is defined by sigma equals the square root of the sum of x minus the mean squared times the probability of x. The standard deviation of a discrete random variable can also be obtained from the computing formula sigma equals the sum of x squared times the probability of x minus the mean squared. Using our example where we have x equals 1, 2, and 3 and their respective probabilities are 0.6, 0.1, and 0.3, obtain the standard deviation sigma of the random variable. So using the formula, sigma equals the sum of x squared times the probability of x minus the mean squared equals the square root of 1 squared times 0.6 plus 2 squared times 0.1 plus 3 squared times 0.3 minus 1.7 squared. This result is 0.9, so the standard deviation of the probability distribution is 0.9. In this example, find the mean and standard deviation of the random variable. The random variable x is the crew size of a randomly selected shuttle mission. Its probability is shown below. For x equals 2, the probability is 0.046. For 3, it is 0.046. For 4, it is 0.075. For 5, it is 0.336. For 6, it is 0.237. For 7, it is 0.225. For 8, it is 0.035. So we want the mean and standard deviation. We want to use our calculator to help us find our mean and standard deviation. So we want to go to Stat, Edit, and we want to type our data in L1 and L2. So in L1, I'm going to type 2 through 8. Then in L2, I'm going to type their respective probabilities, 0.046, 0.046, 0.075, 0.336, 0.237, 0.225, 0.035. Now that our data is entered, we want to go to Stat, over to Calc, one variable statistics, enter. We want to type L1 for our list, for our frequency list, Sec2, which is L2. If your calculator doesn't have the Stat wizard, Stat, over to Calc, one variable statistics, enter, and we want second L1, comma, second L2, and then press enter. Either way, when we press enter, we should get our mean as 5.487 and our standard deviation as 1.37398. So with 3 decimal places, our mean is 5.487 and our standard deviation is 1.374. Using the same data set, example, draw a probability histogram for the random variable. For this histogram, we want our random variable x to be the x-axis 2 through 8, and then we want our probability to be our y-axis 0 through 0.5. Going to our calculator. To see the graph of the data, go to Second, Stat Plot. Make sure one of the stat plots is on. Choose Plot 1, enter. Make sure the type of graph is histogram, then enter. Make sure the X list is L1 and the frequency list is L2. Go to Window. We want to start the graph at 0, 0. X-min equals 0. X-max equals 10. Since the max volume is 8, we want some room to the right. Leave the X scale at 1. Y-min equals 0. And Y-max equals 0.5. Since it needs to be a little bit larger than our maximum probability of 0.336. Leave defaults for the rest. Press the graph button. Now there is a graph of my data. I can use Trace to see the X and Y values of each bar. So I have now constructed a probability histogram for the random variable. To recap the mean and standard deviation of a discrete random variable, the mean of a discrete random variable is labeled mu and is defined by the sum of x times the probability of x. The interpretation of the mean of a random variable: the larger the number of observations, the closer the average tends to be to mu. Also, the mean of our discrete random variable is the expected value of the variable. The standard deviation mean of a discrete random variable is sigma and is defined by the square root of the sum of x minus the mean squared times the probability of x.